Hello everyone, welcome to 369 Chemistry, and in this video we will discuss about the stability of the carbocations. So we have totally discussed about our SN1 reaction, SN2 reaction and all. So here in SN1 reaction, the important to note is that the rate determining step considers a carbocation. What is a carbocation? We know a carbocation is something which is a positively charged, okay, and it's very much reactive. Okay, so that carbocation, which one will be the most stable, you have to determine that. So for a carbocation to become more stable, the only two most important phenomenon is your resonance and hyperconjugation effect. So the more the resonance structures or the hyperconjugation structures, the more is the stability of the carbocation. So see here in this chart, I can show you that you have tertiary benzylic, secondary benzylic, and your primary benzylic. Okay, then you have which is more stable than your tertiary carbocation, then secondary, then primary, then comes vinyl and phenyl. So vinyl and phenyl are the least stable carbocation. Why? I'll explain. See here, in the first molecule, that is your tertiary benzylic, there you have resonance structure, resonance due to phenyl ring. Also you have three hyperconjugation structures, which is also called no bond resonance. That means hyperconjugation depends upon the carbon atom, okay, the carbon atom which is adjacent to the carbocation carbon, positively charged carbon. That carbocation, that carbon has to have more number of hydrogen. So the more number of hydrogen it will have, the more hyperconjugation structures will be there, which is no bond resonance. So we have discussed about hyperconjugation in our other videos. Please go through that. So here what happens here, there is 9 hyperconjugation structures. Also it has you can say it has the property of resonance. So this is the most stable. Then comes to secondary benzylic, where you have 6 hyperconjugation structures due to the 3CH3 2CH3 methyl groups, and in the first one, tertiary one, it had 3 methyl groups. Okay, so in benzylic one, only 1 methyl group is there. So 3 hyperconjugation structures and resonance. Okay, so these are most stable. Then comes your tertiary carbocation is also stabilized due to 9 hyperconjugation structure. Secondary carbocation is stabilized by 6 hyperconjugation structures. Primary is again stabilized by your 3 hyperconjugation structures. Okay, this way we determine the stability of carbocation. See here, the allylic one and the secondary allylic and primary allylic, it is not there in the decreasing form written. Why? Because the secondary tertiary allylic, okay, and tertiary benzylic carbon is more stable than your tertiary carbocation. That also we know. Okay, secondary allylic is more stable than your secondary tertiary carbocation. Okay, and your primary allylic is also more stable than your secondary alkyl carbocation. Why? Because the allylic group, here you have a double bond, okay, and you have a positive charge which is in resonance with it. So not only it has hyperconjugation structures, okay, but it also has resonance. Whereas in tertiary carbocation or secondary carbocation or primary carbocation, it is only the hyperconjugation structures which determines the stability. Whereas in allylic, there is also a little bit of resonance is also there. Not resonance of the phenyl ring, but still resonance is there. Okay, so the resonance due to positively charged cation and ion, and that your double bond. So you can say this way they are more stable than your tertiary carbocation also. So and remember that vinyl carbocation and your phenyl carbocation, they are very slow reactive towards your SN1 or SN2 reaction. Why? Because they are not stable at all. Okay, here you can see this positive charge, and this there is double bond also. So it is already deficient, and and it becomes more deficient because the carbon becomes more deficient, and hence it is most unstable. Even this phenyl cation, though there is resonance inside the ring, outside where there is a positive charge, it is very much unstable. So this one does not go for your any SN1 kind of reaction, it does not go for. So stability of carbocation is also very reactive because it has it does not have electrons, it has less of electrons, so it will try to take up electron and becomes stable, very highly reactive.